Okay, guys, welcome everyone. And today we're gonna be introducing to you guys how to solve systems of equations. And so first, we're gonna begin by looking at basic one variable equations because obviously systems of equations are based on one variable equations. So by being able to solve them, it will give you a good foundation for solving harder systems of equations. So as written, these equations are extremely easy to solve. We simply combine like terms and then isolate the variable. So if the English sentences are a bit confusing to you, you're going to see what we mean by this very soon in the next example. So this is our first example. So we want you to solve the following equation. So guys, how would you solve this equation? And I think the answer might be pretty obvious. Does anyone want to try this? You can feel free to unmute or just type the answer.
X equals 4.
Nice. Okay, so obviously this is a very simple equation, but using analytical methods that you would use to solve harder problems, you would divide both sides by 2. So Jonathan, if you would like demonstrate.
Oh, wait.
So obviously you just divide both sides by 2 and you get x equals 4. And you can always think of an equation like a scale, like one of these scales where there's like 2 plates on each side and it's like weighing. So the idea is that if you have 2 weights on each side, then if you do the same thing to each side, then you will always get the same answer and you always have both sides being equal to each other, which is why we have to divide both sides by 2. Okay, so this is a very simple example. So let's go to the next example. So this one is slightly harder. So we want to solve this equation. And as stated on the first slide, we want to combine like terms and then isolate the variable. So like terms are 5 and 14 because 5 and 14 don't have variables. So you would want to combine them so that you can isolate the variable over here. So Justin says that x equals 3. And I think that is correct, Justin, but why don't we go ahead and solve this using analytical methods? So the first step is, as Jonathan wrote, we subtract 5 from each side and you end up with 3x equals 9, right? Just like that. Because if you subtract both sides by 5, the 2 sides remain equal. Okay, so now that we have 3x set equal to a single integer, we can easily solve this equation. So we can just divide by 3. And we end up with x equals 3. So this is a simple demonstration of how you would solve a basic one variable equation. Okay, so now let's move on to a third example. It's slightly harder. Does anyone want to give this equation a try? How would we start this?
So it's important to remember, just like how you combined like terms earlier with the 5 and 9 or something, here we have combining like terms again. So start off with that. Maybe that gives you a little hint. Oh,
Guys, why don't you tell me what is the first step you would take in solving this equation? Like, what's the first thing you would do?
Add 9x to 3x.
Exactly. Because if you add 9x to both sides, then you combine the terms with an x, and thus you achieve combine like terms. And for those of you who still don't quite get what we mean by like terms, as you can see, 3x and 9x both have an x in them. So we want to combine them. Now that we have 12x equals 48, the answer should be pretty obvious. Someone tell me what it is. And it's 48 divided by 12. 4. Yep, Justin, you're exactly right. So x is equal to 4. Great. Okay, so now we have this equation down too. So does anyone have any questions so far regarding how we're solving these equations? No? Okay, great. So now here's an even more hard example. So again, what's the first step you would take in solving this equation? Rose, I just got here. Oh, hello, Rose. So we're just talking about how to solve simple one variable expressions, equations. And this is a very simple example that's going to help you build to solving systems of equations. So what would be the first step you take in solving the following equation? And remember, you want to first combine like terms.
Add 40x to 20x.
Great. And the second step obviously would be to add 70 to both sides too, so that we can combine the integers as well. So you would get 60x equals 120. If that was a little fast, but what we basically did is we added 40x to both sides. And we also added 70 to both sides. Like that. So this way, both sides remain equal, yet we have a much simpler equation that we can solve for the answer. So 60x equals 120, meaning the answer would be 2, right? Very simple. So x equals 2, and that is the solution to this equation. And just to define the term solution, it's basically the value of x that would make the equation true. So for example, x equals 2 here is the solution to the equation, because plugging in x equals 2 would make both sides negative 30. As you can see, the left side equals 40 minus 70 equals negative 30. And the right side is equal to 50 minus 80, which is also negative 30. And thus, this is a way to check that you indeed found the correct answer. All right, are there any questions before we move on? No? Okay, great. So here is one more example that is slightly more hairier. So what would be the first step we take in solving this equation? Well, again, we want to combine like terms, right? And Kevin says to add. That's a great idea, Kevin, but what exactly should we add? Feel free to unmute. Kevin says add 11x and 29. And to add 5x and 47. So Kevin, I think you're on the right track here, but you do have to realize that when we added values in the previous problems, after we added it, the variables only appeared on one side, right? Remember, for example, if I go back to this problem right here, remember that we added 40x to both sides, but then that means we end up with 60x on the left side. So the variable only appears on the left side. And we added 70 to both sides, but that meant that the integers is only on the right side. So we end up with this. So as you can see, it's really nice because the variables are on one side and the integers are on one side. That makes it really easy to solve. So in this problem, I think, Kevin, instead of adding, maybe we should subtract. What do you think? Does anyone else have any other ideas?
Again, Kevin, we can't add 11x to 29 because we're not sure what x is yet. If you only have 11x and 29, you're not sure how to solve this. That's where the other side comes in. So to solve this, you try to balance out the equation, move all the variables to one side. And after that, you're left with something that you can easily solve. So how do you think we can approach that?
Right. Well, everyone seems a little stuck. So again, like Jonathan just said, you just want to make sure that the variables are on one side and the numbers are on the other side. And that's really easy to do because as you can see, all you have to do is subtract 5x, right? To get the variables on the left side. And all you have to do is subtract 29 to get the numbers on the other side. So subtracting 5x from both sides gives you 6x plus 29 equals 47. And then subtracting 29 from both sides gives you 6x equals 18. And then finally, you just divide again. So x equals 3. And that gives you the solution to the equation. Does anyone have any questions about this? Justin, are you confused about any part of this? No, okay. Kevin and Lloyd, do you guys have any questions? Caden, do you have any questions?
Nope.
Okay, then I suppose we should move on. Okay, so this problem involves a bit of the distributive property. And basically, the distributive property is that A times parentheses B plus C is equal to AB plus AC. It should make a lot of sense, right? Because if you are multiplying two things together and one of them is two things added, it's just the addition like distributed across. So, but yeah, this is the distributive property. So how will we solve the equation on screen right now?
You do distributive property, so it's 6x plus 36 and 24x plus 36.
That's right, exactly. And from now on, what will we do, Caden?
Then we subtract 6x from 24x.
Great. That leaves 18x on the right side. So now what will we do?
You subtract 36. Wait,
Yep, that's right.
36 from 36.
Exactly. You subtract 36 from both sides and you get 18x equals 0. So what is x?
It's undefined.
It's 0, right? Because 18 times 0 is 0. So 0 would be the solution. You can also divide both sides by 18. And 0 divided by 18 is obviously 0. So 0 would be the solution.
If it was undefined, it would instead be 18 divided by 0. So if it's 0 divided by something, it just equals 0. This here is undefined. So that's not what we got.
Yep, that's right. Good job, Kaden. So does anyone have any questions about this before we move on to, I believe, the final example? No? Okay. Well, then here's the last example, I think. Yep, that is the last example. Okay, so what's the first step in solving this equation? Kevin, would you like to try this problem? Kevin says no. Okay, then. So again, like Kaden solved the problem last time, you want to start with the distributive property, right? To expand all the terms, so you have something simpler to work with. So expanded, you would have 14x plus 7 equals 15x plus 45. And it's just, again, an application of the distributive property. Justin, you are exactly correct. Hey, Justin, why don't you message everyone in the meeting so that everyone else can also see your messages? Because right now you're doing a direct message. All right, thanks. Okay, so after we do this, obviously, we again combine like terms. And Justin, what will we end up with if we combine all the like terms? Feel free to unmute if that's a little easier. Okay, so again, by combining like terms, we want to end up with a variable on one side and numbers on the other side. So in this case, it's really easy. You simply subtract 14x from both sides and subtract 45 from both sides. This way you end up with variables on one side and numbers on the other side. And you would end up with x equals negative 38. And that would be the answer to the following equation. Okay, guys, we're kind of silent today. So is there any questions or is everyone just like confused? And are there any questions? Joyce, are you confused about anything?
By both sides. So when we say both sides, we mean both sides of the equation. So we mean the side here with 14x plus 7, and then the other side with 15x plus 45.
Yeah, actually, why don't we write it out, Jonathan? So first, again, we want to subtract 14x, right? Wait, let me delete these green. Okay. Oh, wait, did I just delete everything?
No, it's okay. Here, I'll write it out.
Okay, so first we apply the distributive property and end up with 14x plus 7 equals 15x plus 45. And as you can see, if we subtract both sides by 14x, then we would end up with variables on one side, right? So this gives you 7 plus x, 7 equals x plus 45. But then we want to isolate the variable x. So we subtract both sides by 45. I love Jonathan's using 2 different colors as a Khan Academy. So now we end up with x equals negative 38. Does that make sense, Kevin?
And again, we're starting off by subtracting 14x from both sides instead of 15x, because that will leave us with positive x. Again, you can subtract both sides by 15x, but if you do that, you get negative x equals positive 38. And again, that's the same answer, but usually it's a little bit easier to keep x positive. So that's why we subtract 14 instead of 15. If that wasn't clear.
All right, then if there isn't any more questions, we shall move on to the actual meat and potatoes of today's lesson, which is 2 variable systems of equations. So final round of questions. If you have any, you better ask now or you're going to get very confused in the following section. 3, 2, 1. Okay, so 2 variable systems of equations. These equations are also very easy to solve once you learn to solve them. So there are 3 main ways we solve systems of equations: substitution, elimination, and isolation. Right now, you probably have zero idea what any of these terms mean, but you will soon understand them with the following examples. So this is example 1, and we're going to solve the following equations, system of equations using substitution. And by the way, when you have two equations with two variables or more equations with more variables, it's called a system of equations. So we want to solve this with substitution. And what substitution basically is that you want to isolate a variable and then substitute that into the other equation so that you end up with one variable. So in this simple example, what was that, Joyce? Okay. So in this very simple example, substitution would basically be you want to substitute x into the second equation. This way you just end up with the equation involving y. And indeed, in this case, x is already given to you. So you just substitute that value into the second equation. And you would get 7 times -10 minus 8y equals -14. And so after that, you would end up with -70 minus 8y equals -14. And so now we just have an equation from the previous section, right? It's just a single variable equation. So again, you combine like terms, you move 8y to the right side, and you add both sides with 14, and you should end up with -56. Then obviously you divide both sides by 8, so y equals -7. So this is basically the essence of substitution. You want to solve one equation for one variable, and then you substitute that variable into the other equation to result in an equation with one variable, and then solve it like a single variable equation. So obviously, in this case, the solutions would be -10, -7. And indeed, when you solve systems of equations, you usually write the answer in this form, and this is equal to x, y. So in this case, the solution is x equals -10, y equals -7. Okay, are there any questions before we move on? No questions? Okay, then. So here is a slightly more difficult example involving substitution.
Okay, so this is similar to the previous problem, but this time we have to first isolate one of the variables. You can choose either isolate x or y first in any of the equations. So which one do you guys want to start with?
And in fact, it's probably easier to isolate the y in the second equations, right, everyone? Because it's just a single y there, so you can just move the x's to the other side. What do you guys think? Agree or disagree? No response. Silence is consent, I suppose. So yeah, so in this case, in the second equation, you already have a y by itself. So it would be much easier to just add 6x to both sides and isolate y. And you would end up with, as Jonathan writes, y equals 6x minus 9. Okay, Kaden, now what do we do?
So remember, for now, we're already done with the second equation. So now we just have to worry about the first one. So can we use the information that we just got to solve the first equation? Remember, the first equation is not solvable by itself because there's two variables, and we have to, if there's only one equation, you can only solve it when there's one variable. But now that we've already found y using x, Do you think we can use that to solve the first one?
Hayden, what do you think? What should we do?
I think we should add 9 to y.
Not white, but Caden, think about the word substitution. So we want to change this first equation into an equation only involving the variable x. And we know that y equals 6x minus 9. So how would we change the first equation into a single variable equation involving x?
So we can use the information we know for y. So we can plug y back into the first equation.
Actually, Caden, how about this? What if instead of 6x equals 9, I told you that y equals 3? Then how would you solve the first equation?
I would replace y with 3.
Great, okay. So if y equals 3, you would replace the y with 3. So then what if y equals 6x minus 9?
Then I would replace y with 6x minus 9.
Bingo, you got it. So again, since we know that y equals 6x minus 9, we can simply replace it, or in other words, substitute it into the first equation. Now look at what we have: a single variable equation involving x only. Now it's just, again, a single variable equation, like the ones we solved so many times. So Hayden, Joyce, Justin, Loy, Kevin, do you guys want to try to solve the single variable equation? Joyce, you want to try to solve it? Okay, Justin, what is the first step you would take to solve this equation? Anyone, what is the first step you would take to solve this equation? Kevin says, I don't really get this. What do you not get, Kevin? Which specific part? Maybe you should unmute Kevin so that there isn't the awkward silence while you're typing. But go ahead and
Feel free to tell us, so we don't have very many people in the Zast circle, so we have time to make sure everyone can understand what we're going through. So any questions, please let us know. We can go back as far as you want to go explain these things.
And you want to make sure you understand these parts, because, okay, Justin says negative 6x minus 48x minus 72 equals 18. Justin, you almost got it. You're so close. So minus 6x and minus 48x are all correct. But notice how you actually have two negative signs. So Justin, would it be minus 72 or plus 72? Yep, so right, I think Justin is retyping it right now. But indeed, it would be plus 72 because, you know, a negative and a negative gives a positive. So when you expand this, you would end up with negative 6x minus 48x plus 72 equals 18. And then you just again combine like terms. The left side becomes negative 54x. And you move the 72 to the right side. Minus 72, you end up with right side negative 54. which means that x is just equal to -1. I'm sorry, it's just equal to 1. So that's the solution. However, we are not done yet, guys, because we found out what x is, but we still don't really know what y is, do we? So how would we find y given that x equals 1?
Again, going
Joyce,
back.
how would we find y if x equals 1? Right, Kevin? Kevin, how would we find y if x equals 1?
So go back, you can go back to when we solved this first equation down here. Remember how we already defined y?
Guys, I'm gonna give you a very subtle hint. Look at the equation in boxing right now.
So this
would-
equation tells you exactly what y is if you knew x, right? So now that we know x, we can use this equation to go find y.
Yep, so Caden, what would y be if x equals 1? Does anyone want to try it? It's very easy. Okay, so again, like Jonathan said, y is equal to 6x minus 9. So that means if x equals 1, you just replace the x with 1. So y is equal to 6 times 1 minus 9. So that means y is just -3. Okay, so that means the official solution to the system of equations would be 1, -3. And that would be the solution. Okay, does anyone have any parts of this solution that they don't really understand? Are there any questions? Okay, why don't we visualize this a bit more by seeing it on Desmos? Okay, let me open a new tab, desmos.com.
Yeah, Kevin, any questions?
Kevin, feel free to unmute.
Like subtraction part, where like 6x minus and like a equals 18, like that part.
Campbell, can you full screen the slide?
Of course.
Like the bottom equation.
Okay, apparently Google Slides doesn't let you present. Oh, here. Okay.
Sorry, where on the screen?
What?
Sorry, which part were you confused about?
The -6x minus 8,
Oh, how he got there?
yeah, equals 18.
Campbell, I think you're on the wrong slide.
I also think I'm on the right side. Sorry, guys.
There you go.
Here it is.
So remember, first of all, we got do you know how we got the y equation here? Let me switch colors. Kevin, do you understand? Oh,
Yeah.
yeah. So now that we have the y, we're plugging this y back into the first equation. So the -6x minus 8y equals 18. That's from the first one. So this is just the -6x minus 8y, and then we're plugging in x. We're plugging in what we got for y down into the y part. So it would be.
And maybe this will help you understand because this helped Caden understand. So Kevin, if I told you that y equals like q, and I wanted you to solve, okay, I'm gonna erase this thing because it's a little messy. So Kevin, if I told you that y equals 1 and I want you to find x in this equation, what would you do? You would replace the y with 2, right, Kevin? Does that seem reasonable?
Yeah.
Right, okay. So then if y doesn't equal 2 and instead it equals this, then what would you do? You would replace y with
Mhm.
6x minus 9, right?
Yeah.
Right, because it's since y equals 6x minus 9, you just have to replace y with that and you get the same equivalent expression. And that is exactly how we got this equation. Does that make sense? It's from here.
And the reason we have to go through and find y first and then plug it back into an equation is because if you only have one equation and you have x and y to solve it, you have two variables, you can't really solve it. So like, for example, if I told you x plus y equals 5, there are a lot of combinations to do this, right? We can have 1, 4, or 2, 3, and so on. There's many answers for x and y. So when we're solving a single we're solving an equation, we need to only have one variable. So if we solve for y first using this equation, we can plug it back into the first one using y. And then now, once we plug y back in, we find that we don't have y anymore. We only have x. And using that, we can find x for sure. And then once we know the x, we can do the same thing to y.
Does that make sense, Kevin? Are you still confused?
Okay, cool. So now we're gonna go back to visualizing.
All right. So allow me to exit. Okay. So I'm going to type this equation, this system of equations into Desmos, and I'm going to show you a correlation actually between systems of equations and lines on the Cartesian plane. Sorry, plus y. Okay, so,
Plus y. That's the blue one. Yeah.
oh. Okay, so as you can see, these equations actually corresponds to lines, right? So as you can see, this equation corresponds to the red line here, and this equation corresponds to the blue line here. And some of you might ask, okay, so why are these blue lines corresponding to these equations? Well, the lines are called the graphs of these equations, and a graph of an equation is simply the set of all points that satisfy the equation. For example, if you look at this point, 1.5 comma 0, and that is on the blue line. That means if I plug in x equals 1.5 and y equals 0 into the blue equation, I would get a true statement. In other words, -6 times 1.5 plus 0 would equal -9. That's why 1.5 comma 0 is on the blue equation's graph, because it satisfies the equation. And similarly, all of these points on the red line are points that satisfy the red equation. In other words, you pick any of these points and you plug it in, and you would see that -6 times this number plus -8 times -1.665 is equal to 18. And so their intersection is actually precisely the solution to the system of equations. Because if you think about it, if the intersection is on both the red line and the blue line, that means it satisfies both the red equation and the blue equation, which is exactly what we do when we solve a system of equations. We find the values of x and y that satisfy them both. This is why they intersect. And as you can see, we got the right answer.
So is everyone here familiar with like the slope form, like y equals mx plus b? Is everyone familiar with that? Like this form here. So like this is a pretty common way to graph a straight line. As you can see, I just moved some of the variables around on the blue and the red equations, and you'll see that they are just straight lines here. They fit the thing. So for the blue one, the slope would be 6 and the y-intercept's -9. And then the red one, the slope is -3/4 and the y-intercept is -9/4. So if you don't know all of that right now, that's not important. But the point is that even though these equations that we have on top may look kind of complicated, they're all just lines here. And once we graph them, the answer for x and y to both these equations is exactly where the two lines intersect. So it's a better way of finding understanding for this.
And in case you are wondering, graphs are not limited to lines. So that means I can graph all sorts of weird shapes using these. And you will learn about these more when you go to middle school or in some of our future lessons. So, but for now, why don't we go back to solving linear equations? Leave. Okay. So now that we know how to use the technique of substitution, why don't we go to another example? This one is slightly more difficult. Does anyone know what would be the first step to solve this equation or the system of equations? Kaden, what do you think? What should we do first?
I think we should do
So do you remember how last time we started off by finding y? So we started off on the last problem by finding one of the variables, right?
yeah.
So do you see an easy variable here that we can solve pretty quickly? So usually good one to start off with.
We could, is it like
Yeah, so last time we picked
X.
solving for y first, right? Because it was pretty simple.
Wait, I think Kaden said X. Kaden, did you say X?
yeah, I think x plus 8x.
You mean X plus 7y?
X no oh wait.
So when we start off, we're just going to pick one equation to work on, and then we'll work on the second equation later on.
I mean, because if you look at a previous example, remember, like, we first solved y equals 6x plus 6x minus 9, right?
Yeah.
And that enabled us to plug it into the other equation. So if we do something similar, what would you do in this equation?
7y equals x plus 25.
Okay, you're very close, but do we want to solve for 7y or should we solve for x? Because is it easier to replace a 7y or is it easier to replace an x?
X.
Exactly.
Sure.
So we would probably want to solve for x, right, Kaden?
Yeah.
Okay, then let's solve for x in this equation. So what would you get x equals to, Kaden?
X equals 7y plus 25.
Is it plus 7y or minus 7y? How did you get x equals 7y plus 25?
Because they're both positive numbers and it has like as 7y has a plus symbol next to it.
Kaden, you're on the right track, but remember, an equation is like a balance scale, right? So if you do the same thing to the both sides, the balance scale remains balanced. But if you only do something to one side and not to the other, it doesn't balance. And so if you want to put the 7y on the other side, obviously you get rid of it on the left side by subtracting it, right? So on the left side, you want to subtract 7y. So you do the same thing on the right side. So that means you should end up with x equals 25 minus 7y. Does that make sense?
Yeah.
Great. Okay. So now that you got this equation, Kaden, what would you what would you do next?
So it's like the next equation, right? We have to do the next equation.
Exactly.
8x equals 20 plus 4y.
Hayden, I like how you get like this solving for variables thing. You're really getting it. But actually, we don't have to do that, right, Hayden? Like, we don't have to do that anymore because we got this equation.
So the reason we went and found x, so remember, it doesn't matter if you look for x first or y first. At the end of the day, we're going to solve for both. But now that we know what x is, we want to use it to solve for the equation with two variables, right? Before we, oh, 1 second. Before we weren't able to solve 8x minus 4y equals 20 because we didn't know either x or y. So there were two variables. But now that we know what x is in terms of y, because there's a y here where x is equal to, we can just plug that back in. And now, after we do that, the equation will only have the variable y. So therefore, we can solve it. Does that make
So
sense?
Go
it
ahead.
would be 8. It would be 8 parentheses 25 minus 7y parentheses.
Bingo, you got it. Exactly. Because since we know x equals 25 minus 7y, you simply replace that. Uh-oh.
My bad.
You simply replace the x with 25 minus 7y, and it remains a true statement, right? So you replace that, and you would indeed, as Kaden said, get 8 times 25 minus 7y in parentheses. Jonathan, you got it?
Yeah, 1 second.
Okay. So indeed, you would end up with 8 times 25 minus 7y minus 4y equals 20. Now, doesn't that look like another single variable equation? So now what, Kaden?
You do 8 times 25 and 8 times 7y.
Yep, bingo. Okay, now Kaden, go ahead and finish the problem.
So 200.
Here, let's move this over to the corner here. Running out of space. 1 second. I'm gonna rewrite it.
You're on the right track, Kaden. 200 minus
200 minus 56y.
well, Kaden, if you have 60 apples and I take 56 away from you and take 4 away from you, how many apples did I take away?
Wait, could you repeat that?
If I first take 56 apples away from you and then I proceed to take 4 apples away from you, how many total apples did I take away from you?
60.
Right, so let's say that we now changed your apples to Ys. If I take away 56 Ys from you and then 4 Ys from you, how many Ys did I take away from you?
60.
So wouldn't the minus 56y minus 4y just be minus?
Minus 60y?
Exactly, you got it. Okay,
Oh.
Kaden. Now
Yeah.
what?
So you're saying it would be 260 or 200 minus 60y equals 20.
Exactly, yep.
So do I subtract 200 on, wait,
Sure.
Yep.
so I subtract 200 on both sides to the 20.
Yep, minus 60y equals negative 180. Now we're done, Kaden. What's the answer?
Negative 60y equals, or y equals 20 or 2 or 3.
3. Yep, brilliant, Kaden. You just solved the whole system of equations. Congratulations. Brilliant, brilliant. Okay, everyone else, do you guys understand how Kaden solved the system? Are there any questions?
Yeah, so nothing to add on. If there's a lot of terms here on one equation, it may look kind of intimidating, But remember, we don't always need to start off with isolating the variables and combining all of the constants. We can start by first combining like terms that we have on each side first. So like Hayden did here, combining the negative 56y and the negative 4y. Yeah,
All right. No questions? Okay, then let's go on to a different technique. Okay, so here's the second technique, elimination. And the key idea of elimination is to manipulate the two equations such that you can add them together or subtract them together, and one of the terms just vanish and you just magically end up with one variable. So as a demonstration of this idea, notice what happens if we add these two equations together. In other words, you add the left side together with the left side, and you add the right side together with the right side. Then what would you get? You would get x minus x plus y minus 7y, right? You would get x minus 7y plus y. And on the right side, you would get 18 plus 18. And then, so the x's obviously cancel to 0. So you would get negative 6y equals 36. So y equals, uh-oh.
Oh, wrong
Did
button.
I do that?
No, that was me. 1 second. Oh,
Oh,
technical difficulties. I guess I'll rewrite it 1 second. My bad.
okay.
Now,
Well, it's a review for everyone. Okay, so again, you would get negative 6y equals 36, right? So y equals negative 6. So as you can see, this is actually, if you can use elimination, it's much easier than substitution because you can just add the equations or subtract the equations together, and you just magically cancel out one of the variables. And you don't even have to do any substituting, and you already have a single variable equation. And moreover, when you use elimination, usually you get like a super simple equation like this, like something times something equals something. You won't get anything like complicated like 6y plus 30 equals like 20y. You wouldn't get anything crazy like that. You just get a nice and simple equation like this, which is why elimination is a really nice technique. Okay, we're gonna reinforce this with some examples, but before that, does anyone have any questions? Nope. All right then. So here is the next example. So in this case, again, we want to somehow combine the equations so that we can put them together and cancel out one of the variables. So what might we do in this case? Does anyone have any ideas? Justin, what do you think we should do in this case? Caden, do you have any ideas? Justin, oh no, Kevin says to add. Kevin, if we add, what equation would we end up with? You can go ahead and voice it out, Kevin. It's easier than typing.
Is it like, are they both negative sixes or is,
yeah, they're
They're
both
both
negative.
negative.
okay. So then would it be negative 12x? And then 8y minus 8.
You're right, minus 8y, but then we plus the y, right? So
Mhm.
it would be minus 7y, right? Okay, Kevin, what would the right side be then if you add them up?
And then it'd be. Wait, let me think.
Just the right side of these two equations.
18 minus 9, right?
Mhm.
Right, and that's just 9.
Then 9.
So, right, Kevin, you're correct that adding the equations together gives us this equation. But I think, Kevin, although you are indeed correct, we should think about whether or not this equation is useful to us, right? Because what can we do from this equation? It's really, we can't really do anything, right? It doesn't really help us in any way. But Kevin, what if instead of adding, we subtracted? What do you think that would happen? Kevin, why don't we try subtracting?
Wouldn't it be 0x?
Exactly. Negative 6x minus another negative 6x is 0. That means we cancel out the x, which is exactly what we're trying to do, right, guys?
And then. Wait,
So you have negative 8y minus another y. So what would that be? Negative 9y, right? Oh,
oh, mhm.
Yep.
And then. Would that, instead of subtracting the 18 and the 9, would we add the 18 and 9?
Exactly, Kevin. You subtract the negative 9 is equivalent to adding a positive 9. Right, so it's 18 plus 9. Okay, Kevin, finish the problem. What's y?
Wait. 3? Would
No.
y be 3?
you're very close. Remember, it's a negative 9 times y equals positive 27. So what would the y be?
Oh, okay. Then would it be negative 3?
Yep. Yeah, two negatives make a positive, right?
Precisely. Very good, Kevin. That's exactly right. Okay, so now let me help you guys finish the problem. So the thing with elimination is that after you get one of the variables, you do have to solve another pretty complicated single variable equation, although not that complicated, but slightly more complicated. Because in this case, you would plug y back into the second equation, right? So you would get negative 6x minus 3 equals negative 9. And so obviously, if you do a little combining like terms, you would get negative 6x equals negative 6, so x equals 1. So the solution then would be 1, negative 3. All right, so we still have one more technique to cover, but we're kind of running short on time. So we're gonna quickly show you the final technique. And there's a lot of other examples on these. There's a lot more practice questions that we will post on the website and the WeChat group, so that if you want to try them, you can go ahead. And if you have your solutions, you can feel free to post it in the group. And if you want, you can also share your solutions in the next class meeting. Okay, so finally, the final technique we use is isolation. And basically what isolation is that you isolate the same variable on both equations. And after you get the same variable on both sides, you set the opposite sides equal to each other. So for example, as you can see, y is equal to x plus 1, and y is also equal to 2x plus 3. So if y is equal to x plus 1 and y is equal to 2x plus 3, that must imply that x plus 1 is equal to 2x plus 3, right? That seems pretty reasonable. So that means you simply solve the resulting equation, x equals 2, implying y equals 3. So this is the essence of isolation, which is setting stuff equal to each other. And here's another example to make it a bit more concrete. So in this case, we have 3x equal to y plus 16 and 3x equal to negative 5y plus 4. That means the right-hand sides must be equal to each other, right? So as a result, we have y plus 16 equals negative 5y plus 4. That means 6y equals negative 12. So y equals negative 2. Negative 12. Haha. Yep, okay. Right, so another pretty easy example of isolation. Now it's your turn to try. Uh-oh. So indeed, equations aren't always that simple, but you can always make it simple using isolation. So again, isolation, you want to isolate the same variable for both equations. So how will we do this question in this case?
So we can see on the bottom equation, we already have x isolated, right? So that would point that we need to try to isolate x on the top equation. So how do you think we can do that?
Hayden, how should we manipulate the top equation so that's set to x equals something?
X equals 16 minus 3y minus 36.
Precisely. You're exactly correct. All right, then. Now what, Kaden?
Turn x into 16 minus 3y minus 36.
I mean, that's not wrong. That's right, Kaden. So if you turn x into that, what would 16 minus 3y minus 36 equal?
26 minus 3y.
I think you're on the right track, Kevin, but I just want to underline these two equations for you.
Yeah, so Kevin, Kaden, you're right. You can simplify the side here. You can simplify it to negative 26 minus 3y. But after we've done that, we want to keep in mind that x here, and we have another x here. So both of these two equations, or both of the right sides here, are equal to x. So therefore, what should they be equal to?
I did my math wrong, so isn't it actually negative 20 minus 3y, or yeah.
Oh yeah, my bad. Oh yeah, I didn't catch that.
So
yeah, but now that both of these are, so we have negative 9y plus 40, and we have negative 20 minus 3y, and they're both equal to x. So therefore, because they're both equal to x, we can now set them equal to each other, right? So
yeah.
y plus 40 is equal to negative 20 minus 3y. And then now we can solve for the single variable equation.
All right, Kaden, you want to finish the problem?
So add 3y to negative 9y.
That works.
So then subtract 40 into negative 20. And then divide negative 60 by negative 6 to get 10.
There you go, you're correct.
Great job, Kaden. Although we still have to solve for x, right? But it's very easy. What is x, Kaden?
X is X is -50.
That's
Exactly.
right.
So does everyone understand this concept here? What we're trying to do is, so we already have one equation here equal to x, right? So we set the top equation also equal to x. And then now that both of these are equal to x, we can set them equal to each other. And then we solve for y, and then we plug y back in to get x. All right, so sorry everyone for going a little bit over time today. We'll continue this next week, maybe also add on a little bit more. But again, the slides will be up on the Discord, on the website, and on the WeChat group. And yeah.
But if you have an intense compassion for acquiring more knowledge, you can stay after for a few minutes and we will go over a couple more problems. But otherwise, class is over. Thank you for coming.
Thank you. Bye.
Thanks. Bye.
Bye, Justin.
Adios, everyone. Bye, Kevin. Bye, Joyce. Or are you guys staying after? Okay. All right, then. Bye, Kevin.